I want to just talk about calculus and this idea of rate of change. Okay. I've drawn this picture before for you, and I want you to do it again. So here's your x, here's your y. Can you please draw a graph like this? Okay. And once again, in calculus, what we're trying to do is we're trying to. Okay, can I get you to seriously stop the chatter? Seriously, okay? Okay. What we're trying to do is we want to define the idea of a tangent line for values close to this point A. So you're going to have this value A somewhere here, okay? And the idea is in calculus, we don't want to have what we call a secant line. We don't want this, okay? That's not good. That's the secant line. What we're trying to do in calculus is we're trying to find the tangent line right there, okay? Tangent line. Okay. So once again, I want you to just make a note that, yes, a tangent line means that it doesn't touch, or it does touch only at one point. But notice I put a little note here that says, well, be careful. Okay, it means that it can actually touch down here. So if I were to extend this graph, and this graph was like this, yeah, your tangent line can extend and touch there, but it's okay. Because all I'm really worried about is what happens in the region that's close to the point A. So yes, in the end down here, it could intersect, but let's say right now we're just looking at values close to A. Okay? So my question to you, and we've done something like this before, is how would you find the slope of the tangent line at a point, let's call it x equals to A? Well, what we did earlier was, hey, we found 2 points, right? We found the slope between 2 points. And let me describe the other point as this point right here. And I'll call the distance between A and this point h. So the x-coordinate of this point will be A plus h, okay? So can you please draw that on your picture? Not only do we need to know the x values, we need to know the corresponding y values. So I'll call this point here f of A, and I'll call this point over here f of A plus h. All right? Now, right now, I've given you 2 points. They are both on the graph of the function f of x, but they're pretty far away. So how do you find the slope between 2 points on the curve? So once again, here are my 2 points, a comma f of a. And my other point is a plus h comma f of a plus h. So using this, can you tell me how you can find the slope? Plug it into the equation from grade 10, good old grade 10. y2 minus y1, x2 minus x1. So you can sing it. I had a headache yesterday night. I can't sing.
What, after the
Did I have nightmares? No. You mean never again will I want to go on a field trip with an AP chemistry class?
Excuse me.
Just joking.
Let's go.
You want to go on a picture with me?
East side downtown.
All right. Back to calculus, please. Okay. So, ladies and gentlemen, you see what I've done here? I've actually calculated, using the points that I gave you, the idea of the slope, right? y2 minus y1 all over x2 minus x1. Now, notice I'm asking you for the slope of the tangent line, but this formula looks like it's the slope of the secant line, the one in blue. So how do I make a secant line look like a tangent line? The idea is you want to move this point, which I'm going to highlight in green, and you want to move it where? Closer and closer to the point in yellow. So if I ask you to move something closer and closer, what is that calculus term we use? The limit, yes. So what do we want the limit of, though? Well, we want the limit, yes, of that expression that we had from above. Okay. But what do we want the limit to be? So if I asked you to move the green point towards the yellow point, what's the value of h getting closer and closer to? H is getting closer to A? Careful. H is the distance between A and A plus H here. So I want this distance to get smaller and smaller and smaller. How small do I want h to be? Yeah, I want it to be close to 0. Okay? So this is the extra piece you put in, extra part, to make the slope equation the slope of the tangent line. Okay? Okay. So once again, ladies and gentlemen, I'm trying to show you that, hey, this calculus stuff is really an extension of the grade 10 stuff, but the only difference now is that you have this limit of h approach to 0 in front. Okay? Now, in this blank underneath, it says, therefore, the slope of the tangent line in x equals a is given by this function. Limit of h approach to 0, f of a plus h minus f of a over h. Okay? And when this limit exists, meaning when there's an actual number, this limit has a special word. And Megan, what's the word? Yes, it's called the derivative. Okay? Derivative is the key word. Now, by the way, for those of you taking calculus next year, you'll hear this word derivative, derivative, derivative a lot. Okay? Almost for like 3 months. And then you'll hear something called antiderivative. You're like, whoa. Okay? Now, there's a special notation as well, and math people use this notation. It's called f prime of a. Okay? This is said, we say it as f prime of a, and that's the notation for the derivative. Okay? Johnson, you ready? So ultimately, after all this, what I want you to understand is that the slope of a curve at this function at a point a comma f of a is given by this. Okay. It's the limit of h approach to 0, f of a plus h minus f of a all over h. And for those of you who are taking calculus, please memorize this. I don't have a formula or song for this, but you'll need to know this formula for sure. Okay? Shh. I remember when I did my first university midterm, one of the first questions was, use this formula to calculate the derivative. And that was like 1 page. There you go. That was one question. Okay? So, make sure you memorize this. Okay? On a university midterm? Shh. Now, take a look at example number 1 on page 3. Here, I'm going to ask you to do this algebraically. Find the slope of the tangent line at y equals to negative x squared at this point 1 comma negative 1. Now, you might have thought, hey, Mr. Lee, didn't we do this question before? And the answer is, yes, you did. Okay. We did this the first day we did calculus, so let me show you that really quickly. Over here, remember the first day we did calculus, this problem? Hey, look, find the slope of the tangent line to the same function at the same point. And what we did the first day was we used our calculator to kind of estimate, and we found the value of negative 2. Well, today I want to do the exact same question, but this time I want to show it to you algebraically. Okay? So what I'm going to ask you to do is use that formula that we just created, the limit of h approach to 0, f of a plus h minus f of a all over h. And this formula, once again, determines the slope, okay, of the tangent line. Okay, at point A. Okay, so ladies and gentlemen, what is A in this case? What's my A value here? 1. Right, it's the x value or the x coordinates. Okay, so there's your A, and therefore the corresponding y coordinate must be the f of A. Okay? All right. Now, what's my function here, too? What's the equation I'm looking at? What's the equation here? It's y equals x squared. Now, remember, y can always be written as function notation f of x. So if you like this function notation, that's good. Okay. let's see what we have to do now to calculate this limit of h approach to 0 of this ugly function. Okay. Well, what is a again? You told me a was the number 1. So I'm going to ask you to replace a with 1. So f of 1 plus h minus f of 1 all over h. Okay. Now here's where it gets confusing, so listen up for those of you who are doing calculus for sure. Okay. What is this f of 1 plus h equal to? So this is that function notation stuff that we did before in grade, I think, 10. What I'm going to ask you is, notice f of x is equal to negative x squared. So if I said f of 1 plus h, what do you think that's going to be equal to? So wherever you see x, what do you replace it with? 1 plus h. Okay, that's that function notation stuff. Do you see that? Okay. So therefore now, over here, I'm going to now replace the f of 1 plus h with negative bracket 1 plus h all squared. Okay. Okay. And now, what's this f of 1 value? That's right, it's negative 1. It's the y value that's connected to the value at a. When this is negative 1, so I'll say minus, and I'll have here negative 1, all divided by h. Good. Now, you might be asking, Mr. Lee, why do we spend all that time doing limits? Well, this is why, because you're calculating a limit now. What happens if I plug in 0 right now for h? What do you get? You get 1 plus h will be 1. 1 squared is 1. Negative 1, take away negative 1, that's 0. And then bottom is 0. Uh-oh, it's 0 over 0. What do we do when it's 0 over 0? Expand and try to simplify and get rid of that h in the bottom. So let's go ahead now and expand and simplify, please. Okay. 1 plus 2h plus h squared. 2 negatives here must become a positive, correct? Okay. Keep going and try to simplify this, please, and let's see what you get. I will distribute the negative inside. Okay. Okay, I trust you can do the algebra on your own, so I'm just going to quickly write this down. Okay. Now, I've done some expanding, I've done some simplification, but wait a minute, I still can't plug in 0, because I still get 0 over 0. Can someone suggest to me what I can do now to help me get rid of that h in the denominator? Yep. Factor out the h. I like that. We'll factor out the h. We get negative 2 minus h all over h. Cancel, cancel. And look at this now. Now we have the limit of h approach to 0 of negative 2 minus h. And I think now I can plug in 0 and get a nice answer. What's my answer here? Well, it's just negative 2. And that was exactly the same answer that we got on the first day I taught you calculus. But now I showed you how to do this using algebra. Okay? Okay. By the way, this one also asks you to find the equation of the tangent line. So from here, how do we find the equation of the tangent line? What's the good form for the line equation? Y equals to mx plus b. Thanks, Hisham. Do we know m right now? We have m. That's negative 2, right? Cool. How do we find b? How do we find b? Plug in a point. Which point, Sahil? 1, negative 1. Excellent. So take that point that was given to you, plug it in, solve for b. I believe b is equal to 1. And therefore, just like first day, you have the equation of the tangent line as y equals negative 2x plus 1. Awesome. Okay. All right, ladies and gentlemen, I want to see if you can do this on your own. Okay, so the exercise underneath is something that's very similar to what we just did. Okay, I will help you get started, but I want to see if you can do the algebra and everything else to get not just the slope at 4, but also the equation of the tangent line at 4. Okay? So, I'm going to ask you here to once again find out f prime of 4, meaning your a value here. So in this case, a is equal to 4. Therefore, if you're going to use the formula, you have this. Okay? And just to let you know, f of x equals to root x. And you have to figure out what f of 4 plus h is going to be then. Anyone have a suggestion of what it should be? Root of 4 plus h, yeah. Okay. So I'm going to let you try this right now, okay? Take a look. See if you can start working on this and see if you can find out what the limit is going to be. I saw a lot of you do this, which was good. I saw a lot of you replace the 4 plus h with this. And then f of 4 you realize is just root of 4 all over h. Congratulations if you got that. But then I think half of you got stuck after this. You're like, what to do next? How do you evaluate limits like this when there are square roots?
Square it.
No, don't square it. Multiply by something, the conjugate, right? That's the word, right? When you have two square roots, you multiply by the conjugate. So remember, the top and the bottom have to be the same because you're multiplying by 1. You're not changing the value. And then when you do this, remind yourself that this is like a binomial multiplied by another binomial. And so let me show you what you should have. What's root 4 plus h times root 4 plus h? 4 plus h, right. Then you got root 4 plus h times root 4, and then you got this one over here that's also the same thing, but there's a minus sign, so they just cancel each other out. And the last term is root 4 times root 4, which is just 4. Okay? And the denominator, I'm not going to ask you to multiply it out, but I do want you to just replace, or not replace, but combine them together. Oops. Combine them. So h times root 4 plus h plus root 4. Okay? So remember the good old conjugate when you see square roots. Okay? That's how you do it. This is good. Because now what happens here, you should be able to do some simplification, especially in the numerator. What's 4 plus h minus 4? H. Oh, look at that. Do you see now why I did not multiply the h in the denominator? Because look, h, divide out. And by the way, when you do this, put a 1 here so you know that there's still something up top. A lot of people don't, and they think, oh, it's 0. It's not 0, it's 1. So 1 over root 4 plus h plus root 4. And then now you should be able to calculate what the number is going to be. When h is 0, root 4 is 2. 2 plus 2 is 4. So I believe the slope at x equals to 4 is 1/4. Okay. Now go ahead and find the equation of the tangent line, because you're not done yet. Don't forget the equation of the tangent line. So good old y equals mx plus b. See if you can try that, please. So go ahead and try line parts. And Jonathan here says that the answer is y equals to 1/4 x plus 1. Agreed?
Yeah.
Okay. So wait, should I do this for you? Show you?
Yeah, there's something wrong with that.
Okay, I'll show you. Y equals to 1/4 x plus b, right? Now, how do you solve for b? What's the coordinate of the point that we're looking at right now? It's 4 for the x value. So what's the y value? Root 4, which is just equal to 2, right? 1/4 times 4 is 1, so 1 plus b equals to 2. Yeah, b equals to 1. Jonathan's correct. Yay. Okay. All right. The next question, example number 2. Hey, we've done something like this before as well, okay? This is the one where on the first day I also asked you to do this one about a velocity of a free-falling coin. And we talked about how it falls off the cliff or the skyscraper, and you had to figure out the velocity. And more importantly, in calculus, we don't talk about just general velocity, but we're talking about the instantaneous velocity at this moment in time. Okay? Now, for this question, I'm going to say, can you find me a formula that describes the instantaneous velocity at time t equals to a? So I want to generalize this now, okay? No longer do I want you to plug in a number for a, because I don't want things at that particular point. I want to see if you can come up with a formula that describes the instantaneous velocity at any value of a, okay? Now recall that the instantaneous velocity is the slope of the tangent line, and that new word that we learned today that starts with a d is called derivative, right? Then you should have said it. Now you're too late. So, how do we calculate the derivative? Here's what I want you to find. I want you to find f prime of a, which is equal to the limit of h approach to 0. That lovely formula, f of a plus h minus f of a all over h. Okay. Now, before we start plugging in things, what's the formula or what's the equation I'm going to use in this particular example? I'm asking you to find the instantaneous velocity, and I've given you the equation up here. It's this displacement equation. So perhaps I'll say f of t equals to 4.9 t squared. And so my question to you now is, how do you figure out f of a plus h? And this is the hard part. What will it be? What will this be? 4.9, yeah, times? What goes inside the bracket? A plus h, right. Okay. Function notation. So ladies and gentlemen, let's go ahead and do this. That'd be 4.9 a plus h all squared. Now, what's this f of a? Well, I think f of a would be just 4.9 times what squared? Well, not a, yeah, a. We're using the variable a, so let's use a. Yep, so minus 4.9 a squared all over h. Okay. By the way, this step's the hardest part, just making sure you understand what to plug in, especially this function notation stuff. Okay, so that's the hardest part. Go ahead now, please, and solve. Okay. Once again, if I were to plug in 0 right now for h, you'll get 0 on the top, 0 on the bottom. That's bad news. So you have to do some algebra. How about expanding, then simplifying, and then figuring out what this is going to be? Okay. Go ahead now. Do some algebra. So, Gavrilo, like how you said, you know, this limit h approaches 0? Yeah, it's there, right? Now, I haven't finished this question yet, but I did do some simplification so that now when I plug in 0, it will work. Okay, so now when I plug in 0, what are you left with? You're left with just 9.8 times a. And now you see how when I plug in the limit, then the limit h approaches 0 disappears. So it's this last step that you don't write the limit, okay? But everything else before it, you must write these things. You must write them. You must write them. You must write them, okay? So congratulations. What you just told me here, and I'm going to simplify this or rewrite this. Therefore, f prime of a, the slope of the tangent line at a, is given by this formula 9.8 times a. Now, why is it more helpful to leave the value here as a? Because now I can ask you this. I said, tell me what the slope is when a equals to 1. Or tell me what the slope when is a equals to 3. Tell me what the slope is when a equals to 5, right? Now you can figure this out really easily. Whereas the previous question, if I asked you to do that, well, guess what? You have to go through the whole process again. Not so smart, right? So, part B here. Using the formula, can you calculate the instantaneous velocity at time t equals to 3? So what do we do now if I said t equals to 3? That means I want you to find out f prime of 3. Excellent. So let's use the formula that we just created. 9.8 times 3. What's 9.8 times 3? 29.4. 29.4 meters per second, and there you're done. Okay. Now, once again, this is powerful because no longer do I have to do this long limit thing like for every single value of t. Once you've got a value of t, you can just plug it into this, what they call derivative formula. Okay, so how about this one? Can you tell me how fast the coin was traveling just before it hit the ground? Okay. Now, you have to, first of all, for those of you who love physics, tell me what time did it hit the ground? How do I know what time it hit the ground? Do we have a distance formula here or displacement formula? Yeah, that's 4.9 t squared. What distance did this thing travel before it hit the ground? 200, I heard. Yeah, so make d equals to 200. Let's go ahead and solve for t. Please do that right now. 200 divided by 4.9 t squared. Go ahead and solve for t. Bring out your graphing calculator if you have one. Okay. Velocity formula, right. So now let's go ahead and find the velocity. I'll say find velocity by using which formula? By using f prime of a equals to 9.8a. And once again, I'm asking you for f prime of 6.39. Soon. Wow. 62.6 meters per second. So the moral of this story here is don't stand underneath a skyscraper when someone's dropping a coin because it'll come pretty fast and hit you in the head.
Well, actually, that's not going to be the actual speed because after a while, the coin's going to start to reach terminal velocity because of the air pressure to balance it out. The thing is, I'm not that fast. Okay, never mind.
Still pretty scary.
Yeah.
Okay. Still pretty scary. All right. All right. Once again, let me just tell you, in the rest of calculus here, okay? In the rest of calculus, okay, you are going to be always asking for something called a derivative. But I'm going to ask you to calculate the derivative not as a number, but as a function, okay? Derived from this other function that you're creating, okay? So reminder now, I don't want the slope of the tangent line at one point. I want you to give me a general equation that describes the slope of the tangent line at every single possible point on this curve. So once again, I'm going to draw this picture, and you're going to get sick of it, but this is the last time I do it, okay? We've got the function. This time, though, I'm not going to use a. I'm going to use the value of x, okay? So let's call this x. And of course, with a value of x, we have a corresponding y value of f of x. Okay. And then, of course, we're looking for a point close by. And I'll say the distance between there and there is h. So once again, I will draw this coordinate, which is x plus h. F of x plus h. And once again, I'm going to ask you to tell me the difference between the slope of the secant line and the slope of the tangent line. Okay? For one last time. Slope of the secant line is f of x plus h, yep, minus f of x all over x plus h minus x. And of course, I will ask you to simplify this part. So instead of writing that ugly thing, let's just write down h. Okay. And once again, the only difference with the slope of the tangent is, yes, the formula here is the same, but now you have to put in front of it this idea of the limit of h approach to 0. Okay, and once again, notice that in this case, I don't have the a value anymore because I just use x instead. It's just different notation. And by the way, the derivative function, then once again, f prime of x is really equal to the limit of h approach to 0 of f of x plus h minus f of x all over h. And this thing that I asked you to memorize, okay, provided that this exists, this has a special name, and I made a mistake here. It's not his, it's this, is called the definition of the derivative. Okay? By the way, my first midterm question was like this on my exam at UBC. So I remember they said, find the derivative using the definition. And so I had to go and use this formula to calculate and figure out. Yes, of course I got it right. Yeah, I aced my midterm.
As always.
Yeah. Let's take a look. Example number 3. If I ever asked you to differentiate, meaning find the derivative, using the definition, this is what you need to do. Okay? So here's your function. So remember, that's your f of x, x squared plus 3x plus 2. And then you're going to have to use this derivative definition to help us calculate the formula that describes the slope of all tangent lines. And once again, the hardest part is figuring out what this f of x plus h is going to be. Okay? What's f of x plus h if the formula for f of x is the thing I wrote down in blue? Remember, this is function notation, so wherever you see x, you replace it with, in this case, what am I putting inside the brackets? No, that's not what's inside the brackets. Just the x plus h, right. All right, so let's make that substitution over here in our formula. X plus h all squared plus 3 times x plus h plus 2. Now this is just that part in yellow. Please subtract from it f of x, which is x squared plus 3x plus 2. Now be careful. Notice I'm going to put a bracket around there, okay, so that you can see the difference. Okay, time for you guys to do some algebra here. Okay. Go ahead, do some algebra, please. X squared plus 2x plus h squared. 3x plus 3h plus 2. We're going to distribute this minus sign. We're going to divide this entire thing by h. We're going to get very scared because there's so many terms. But you should be able to simplify. Look at this. X squared's gone. 3x, gone. 2 minus 2, gone. By the way, you know you're doing this right if every single term in the numerator still has h in it, okay? So I made a mistake right here, didn't I? Hey. Thank you. Oops. So now what we have here is 2xh plus h squared plus 3h all over h. And like I said, you know you did things correct if there's an h in every single term in the numerator. Because ultimately, you're going to now have to factor. And once you factor, hopefully you can get rid of that h in the denominator. Goodbye, goodbye. This looks good because the limit of h approach to 0 becomes 2x plus h plus 3. And then finally, you can now get rid of that h because you plug in 0. And so your final answer here is 2x plus 3. And what that says is therefore the derivative is equal to 2x plus 3. Ta-da. So another question that says just find the derivative. So of course, the first thing you write down always is that lovely formula that you are getting sick of. Oh no.
Oh yeah.
Oh no.
Wait, so are we having a calculus assignment?
All right. Finish this on your own. Just watch me do the algebra.
Wait, Michelle, when do you want me to come tomorrow and teach me the methods?
You are. I need to finish this first. Just go first. All right. Just give me a sec. Let me finish this.
Can I tell you something after you're done? Make you
Yeah.
laugh?
Give me a sec.